Let's take a closer look at the graphs of functions and inverse functions. So on the screen right now, I have the graph of x squared. That's a quadratic. We know that this is a function. And remember that we said to be a function, each x value can have only one y value. And you may remember from back in Algebra 1, you did the vertical line test. So let me just get a vertical line in here. So I can move this vertical line anywhere through the graph, and notice how it is only intersecting that graph at one y value at a time. This is a function. Now let's put on here, we already did it in example 2a. We found the inverse of f of x equals x squared is plus or minus the square root of x. Now I'm going to have to do this as two separate functions. So I'm going to do, we'll just do the square root. We'll do positive square root of x, there it is. And now we'll do a negative square root of x. So now imagine this whole graph here is plus or minus the square root of x. Now also notice here's your function x squared. When we took the inverse, it's almost like flipping it on its side. Now if I take my vertical line, notice how as I go across each x value, so there, x equals 2, notice I'm going to have two separate y values. That vertical line is touching the graph in two different places. This is not a function. Now also notice, let me get rid of this vertical line. It's being reflected across the line y equals x. That is your inverse function. Let's take a look now. Let's go up to a cubic. So let me change this to an exponent of 3. Okay, so here's your cubic. Let me go ahead and put in a let me put in a vertical line. Here we go. There's my scroll bar. And again, as I move this vertical line, notice it is only touching that graph in one place. Cubics are a function. I could also change this graph to x to the 5th, x to the 7th, x to the 27th. As long as it is an odd function, or excuse me, an odd exponent, an odd degree, it will be a function. Now, what happens when I go ahead and do the inverse? The inverse of x cubed is going to be the cube root of x. So let me get in here. There we go. So now let's take a look. Okay, so it's almost kind of like it's turned on its side. Again, that is a reflection of the line y equals x. And now let's take the vertical line. Let's do the vertical line test and see. Okay, so here I go, here I go, here I go. Now you may think that right here, it might seem like it's touching, but it's not. Those lines there to the left of the 0 and to the right of the 0, those are not right on 0. Your only point that has an actual y value of 0 is at the origin. It is just so close and the decimals are so tiny that it looks like it's on the y-axis, but it is not. So this is a function. It passes the vertical line test. And again, I could keep doing this. We could go, let's change this to 4th degree. Oops, that's a subscript. 4th degree. Go, there's half of it. If it's even, I have to have the plus minus. And let me get back in here to functions. Okay, so there it is. And again, it looks like it's flat here. But again, the only y value of 0 is right at the origin. This is just pulled super close to the y-axis. We have x values here that are going to be very tiny, tiny decimals. Very tiny, tiny decimals. And so this, again, will pass our vertical line test, as does our original function. So essentially, if you have an even degree function, its inverse is not going to be a function. And that's where we usually do domain restrictions, like we saw in topic 5 or 5.3. Yes, when we did the graph of the square root function, we restricted the domain. If it is an odd degree, if you take the inverse, it will remain a function.